Hello, welcome. Let's try to solve another Leetcode problem, 334, increasing triplet subsequence. So for this problem, we are giving an array nums. It's going to be random numbers, and we're going to return true if there exists triplets of indices I, j, k, such that I less than j less than k, and nums I less than nums j less than nums k. If no such indices exist, we're going to return false. So if we read the problem, it's going to become really easy to solve if you know the basic pattern, if you know how to solve it in n log n time for the longest increasing subsequence. Yeah, so this idea is a greedy idea. So the idea is that, for example, we have some numbers like maybe 1, 2, 4, 3, 5. Yeah, we have some random numbers like that, and we are going to calculate the longest increasing subsequence, but we will not use the dynamic programming because that is O(n) square. Definitely it didn't work because the length of the nums array is 10 to the power 5. So this is why we have to solve it in n log n time. Yeah, so for this method, actually it is the greedy idea, and it is also the boundary search idea. So we're going to prepare an empty array. So this is our F array. We're going to prepare an empty array. So for the first number, if the array is empty, yeah, so it means we needed to put the first number inside the array, and because currently it is empty. Yeah. Now we're gonna check the second number, and the second number gonna be more than this one. We're gonna put it here. Yeah. How can we put it? We're gonna use the boundary search to put this number. So for example, if it is empty, we're gonna directly put it here. And for the next number, if it is more than 1, according to boundary search, we're gonna put it here. And similarly for the next number, according to the boundary search, we're gonna put it at the end of the array. And for the next number, it is 3. According to the boundary search, it's gonna be at this place. Yeah. So instead of putting 4 there, we're gonna put a 3 because the 3 is smaller. According to the greedy idea, it might have a possible solution. It might have a better solution if we put 3 here. Maybe the next number is 4. So this is why we're gonna put 3 here. Yeah. So this number gonna be 3. Yeah. Now we're gonna check the last number 5. So according to the boundary search, 5 gonna be here. Now we're gonna check the length of the array. It is 4. 4 is more than and equal to 3, and we're gonna return true, because we just needed to find one of the triplets. If we can find, definitely the length is going to be more than or equal to 3. If it is more than or equal to 3, we're going to return true. Yeah. So now let's just use this idea to solve the problem. We're going to check all the possible numbers inside of the nums, and we're going to use the bisect left because it is strictly increasing. So we're going to check the F array with the nums. Yeah. So the condition is that if I equal to the length of the F array, so this means we need to put it at the end. So we're gonna append this number. Otherwise, if I not equal to length of the array, it means we need to insert it at the place in I. So Fi gonna equal to this number n. And finally, we just need to return the length of the F array should be this F array gonna be a strictly increasing array. So we're gonna check it if it is more than or equal to 3. Now let me just run it and submit it to check if it works. Now as you can see, it works, and it's pretty fast because the time complexity is n log n time. So this is log n time, and this is O(n), and n is 5 times 10 to the power 5. So this is why, yeah, we're gonna use this method to solve the problem. Yeah. So another follow-up is that could you implement a solution that runs in O(n) time complexity and O(1) space complexity? So this is going to be a little bit harder. So we will solve it for next time. I think basically that's all about it. Thanks for watching. See you next time.